Hi, and welcome to our lecture on absolute extrema. So this is sort of a continuation of what we've already learned about extrema in general. And you can have relative extrema, and you can have absolute extrema. So what's the difference between those two? Let's take a look at the next slide here. You can have a relative maximum and a relative minimum. If I point out here, this relative maximum, in its little area of the graph, it is the highest point. But you can see there are points up here that are even higher. So it is not an absolute maximum, it's only a relative maximum. Similarly, down here at this relative minimum, in its little area of the graph, it is the lowest point. However, there are points over here that are lower than it. So it doesn't, we have two relative extrema here, a relative max and a relative min. Oftentimes, there will be instances, and I'll give you an example, where you have a function that doesn't have endpoints like the one that's down below the other example we'll look at. But let's say, for example, you've got a parabola that opens downward, so a quadratic function. This would have, it is not only a relative maximum, because it's the highest point in this little area of the graph, but it would also be an absolute maximum, right, because it is the highest point. So relative maxima occur when they're the highest point in their little area of the graph, and absolute maximums occur when they're the highest point, similarly for minimum. So generally, we would also have extreme points. They could also occur at endpoints. So in this particular example, we are on the interval from -2 to 1. This particular function has an absolute maximum, just like the one that we saw up at the top of the curve. But then since we are cutting off at these endpoints, this point down here, this absolute minimum, is the lowest point on the graph on this interval. So that would be our absolute minimum. That other point is not an absolute minimum or maximum. It's just an endpoint. Okay. We have some other examples on the next slide. Okay. Or I'm sorry, we don't have more examples, but this is the strategy for determining absolute extrema. So we already know that absolute extrema can occur at critical values. So those would be our candidates for where we would have critical values. So we're going to first find f prime and all the critical values contained within the interval. So we're going to have an interval that we're going to take a look at. Then we're going to evaluate the function at all our critical values. And then we're also going to evaluate the function at the two endpoints. Because remember that last example we just saw, the absolute minimum occurred at that endpoint. So the absolute minimum is going to be our smallest of these values, f of c or f of a or f of b, and then the absolute max will be the largest of those values on that interval. Okay? And we also have to assume that f is continuous on that interval. You don't want to have any breaks in the graph on that interval. That's an important part. So these are some examples of the different types of intervals we might encounter. So this first one is what we call a closed interval. It's closed on both ends. Okay, and we saw that it has an absolute minimum at the endpoint, and its absolute maximum is at a critical value, right? Here, f prime would be 0. Okay, on this next one here to the right, we have an open interval. We have an open interval. So our absolute minimum or maxima can't occur at the endpoints, because if I say, okay, this point here is the endpoint. Remember, with the open interval, the open endpoint, we can find another point even closer, and then we can find another one even closer. So we would only have an absolute maximum for this one. Okay. Here is this one on the bottom left is an example of where we have an open hole. We have a hole in the graph up here at the top. So we can't have an absolute maximum. That point doesn't exist there, so we would not have an absolute maximum. And then similarly still, because we have an open endpoint, we wouldn't have an absolute minimum. And then here's where we still have a closed interval, but we still have a hole in the graph. So we still don't have an absolute maximum, but we do have an absolute minimum. So in order to have an absolute max or min, it has to be a physical point on the graph. It can't be a hole in the graph. Okay, so those are the things to keep in mind. So let's try this out. Okay. So remember, our strategy was to find f prime, find critical values, and then evaluate f at the critical values and at closed endpoints. So these are the three things that we'll need to do. Okay? All right, so first thing is you need to find f prime. That should be pretty easy. That's 3x squared minus 12x cubed. And remember, in order to find the critical values, it would be where the function is undefined, where the derivative is undefined, or the derivative is 0. This is a polynomial. It's defined everywhere, so really we're just looking for where is this equal to 0. And we can factor out a 3x squared. That would leave behind a 1 minus 4x. So this is 0 when x is 0, or when 1 minus 4x is 0. That would be when 1 is equal to 4x, or when x is 1/4. So we have two critical values. And we then need to evaluate our function at those critical values, and then also at the endpoints. And we do have a closed interval, so each endpoint is a closed endpoint. So the next thing we're going to do is find f of 0, find f of 1/4, find f of -2, and f of 6. Because our critical values may be the places where we have a maximum or a minimum, right? Those critical values are always our candidates for maximum or minimum. But remember, because we have these endpoints, we might be cutting off the graph at some point where that point where we're cutting off might be higher than our relative maximum or lower than our relative minimum. So we need to find f of 0, so that's going to be 0 cubed minus 3 times 0 to the 4th, which is 0. The next one is going to be f of 1/4. So that's going to be 1/4 cubed minus 3 times 1/4 to the 4th, which if we plug this into our calculator is going to be about 0.0039. Plug in -2, that's going to be -2 cubed minus 3 times -2 to the 4th. I get out -56. And f of 6 is going to be 6 cubed minus 3 times 6 to the 4th. And I get -3672. All right. So we said once we do this, whatever our lowest value is, our smallest value, that's going to be our absolute minimum, and whatever our highest value is will be our absolute maximum. So we have an absolute minimum. Okay, so we would say absolute minimum at x equals 6 is -3672. And then our highest value would be this guy here. It's not very high, but it's still the highest of all of these. So we would say our absolute max at x equals 1/4 is 0.0039. Okay. So again, if you wanted to graph this, you could sort of get an idea of what we're talking about, what it looks like, and you would see that at this endpoint at 6, this cuts it off a little bit below all of the other points. So this point would be the lowest point on the graph.